Hello everyone, myself Dr. Manoj Kumar, working as an assistant professor in Department of EC at MLR Institute of Technology, Hyderabad. Today I am going to deliver a lecture talk on LVDT. So this is my basic overview of presentation. First of all, I would like to discuss basic of LVDT. After that, I will be taking classification. Thereafter, its construction, and finally working principle concluded by some application of LVDT. First of all, we'd like to know what is LVDT. LVDT stands for Linear Variable Differential Transformer. It is mostly widely used as an inductive transducer that converts linear motion into the electrical signal. So here we can see that a linear displacement is there, which is being converted into electrical output. This is the commercial LVDT. It looks like somewhat this type. So LVDT is the device which converts linear displacement into electrical output. So here is the different types of LVDT. So LVDT has been classified as armature based, excitation based, and its working range, and finally it has been classified as a various applications. So here we can see that various types of LVDT based on armature, it has been classified as guided LVDT, unguided, force extended LVDT. In guided LVDT, it is tightly bound to the surface, but in unguided LVDT, it is loosely bound. In excitation type, we can see that there are AC type LVDT, DC LVDT, and digital input output LVDT. When we are giving AC signal for its excitation, that will come under AC LVDT. If you are giving DC signal for excitation, it will come under DC LVDT. And also there are another type, digital input output LVDT. Based on the range, the LVDT has been classified as short range LVDT and long range LVDT. Short range LVDT works within the 0.5 inch distance, but long range LVDT works up to 18.5 inch distance. Based on our application, we have general purpose LVDT, precision LVDT, and submersible LVDT. So here we will see the schematic of LVDT. Here LVDT consists of two winding. First of all, this is called primary winding, another secondary winding. Secondary winding S1 and S2. There are two secondary winding and one primary winding. Here we generally apply a AC input. Whenever AC input is applied in the coil, some magnetic field is generated. This magnetic field, with the help of this core, is being coupled to the secondary winding, and correspondingly we get some net voltage across the LVDT. So this is the schematic of LVDT. So basically commercially LVDT construction consists of a tip, a shaft, a spring attachment for controlling the movement of core, and its two terminals. So here we can see that LVDT is based on the Faraday's law of electromagnetic induction. So whenever the core is moving left or right or at the center position, accordingly the voltage across LVDT also changes. So here we can see that the movement of the core or linear displacement of the core is being measured in terms of voltage. So this is the basic working principle of LVDT. So I would like to explain the working in detail. So when the core moves towards the right side, there are more voltage in secondary winding S2 as compared to S1. So there is net positive voltage. When core is at the center position, so the voltage induced in secondary winding S1 and S2 are equal but opposite in phase. That's why they cancel out and give the zero voltage. Okay, when the core moves towards the left side, in S1 there is more magnetic flux linkage as compared to S2. So net voltage is negative. So in this way, the linear displacement is being converted into electrical voltage based on the mutual inductance in the both secondary winding. So here we can see that one application of LVDT we will see when suppose this is the LVDT and the object is placed here. So here we can see that if object is towards more right side, we are getting more voltage here. If the object is displayed and it is located at the central position, we are getting the zero voltage. If it is moving more towards left side, again we are getting the maximum but opposite in phase as compared to the right side. So in this way, the LVDT can be used to measure the displacement of an object. So application or further application of LVDT is that it is widely used in the robotic systems, in aerospace for balancing the aircrafts, in biomedical also it is being used. So concluding, LVDT is very good transducer which is widely used to measure the linear displacement and its accuracy is very high. That's why we are using LVDT. Thank you.